In 2008, we had the chance to meet one of our major clients of notebook OEM. At that time, we were working on SSD, and it creates a chance for our team. Because we had been working with them for a long time, they feel that our team were capable of manufacturing SSD, and then ship the product to them. After the meeting, we got back and started to discuss how we can approach this goal. First, we've been thinking about what kind of people we will need in the team. This is a new technology, so we have to start from scratch. The important thing about SSD is that it is very expensive, because flash is very expensive. So if an end user has to spend so much money to buy it, it has to have great quality and performance. And that is, its performance must exceed a hard drive's. And also, how can our SSD differ from other SSDs? All part of our concern when we were discussing early on. When we were starting the project, we want to bring something that would be really useful for our customers. So we developed a small program, and we want every employee in our company to install this program in their notebook. What this little program did was recording what kind of data Windows OS would access in a day. Is it a big or a small file? Is it continuous or discontinuous data? After we gathered these information for several weeks, we analyzed these data, and we found that Windows OS uses 4 KB random access the most. From this, we knew that when designing an SSD, the most important things is a good controller. There weren't many options for a controller in Taiwan at that time, so in a situation like this, we chose Marvell. The reason was simple, because Marvell has over 70% of global market share in hard drives market, and because hard drives production is such a competitive market. We believe that Marvell must have their own specialty in hardware design. Also, Marvell was a major manufacturer for SATA I/O, so their product must have good compatibility and performance with SATA and SSD. Besides, we already had some working experience with Marvell when we were developing ODD before, so that's why we thought Marvell's controller would be a good choice for us. There are 3 major components in an SSD: controller IC, NAND flash, and firmware. Controller IC and NAND flash are real and existing parts like a human's body, while firmware is more like human soul, which you can't really see or touch. In order to have a good SSD, you need to have good firmware. And in order to create true speed, we need to depend on firmware's algorithm. With a mechanism we call Instant Restore, we can achieve true speed's performance. It's easy to compare between a hard drive and an SSD, because hard drives have some mechanical limitation, so no matter how bad an SSD is, it will still outperform a hard drive. However, among so many SSDs, which one can truly meet the customer's demand? Garbage collection is a very important factor in SSD performance. Without garbage collection, you cannot clear the storage space for the users in time. Using our special firmware algorithm, our SSD can collect over 10 GB storage space in 500 milliseconds for our users' needs. When the host is sending commands, they won't be like always sending read-write commands, so there will always be some break, perhaps from 300 to 500 milliseconds. And how can we clear enough storage space in such a short time for the user's next command? The command that comes after the break to run smoothly. That is the core concept of instant restore. One of the key functions of LITEON's exclusive TrueSpeed technology is to keep a good sustained performance. And this is made possible by our exclusive Instant Restore algorithm and trim command that are supported in Windows. This will allow our SSD to have a good sustained performance, just like a new product, no matter how full the storage space is. Generally, the amount of data a user will access during a day is about like 20 gigabytes. So assuming we want our product to last for 5 years, then that would be 20 gigabytes times 365 days times 5 years. And that will equal to the total data size of 36.5 terabytes. So when we were developing our product, we designed an RTD test for our SSD. We actually go and write 36.5 terabytes of data into each SSD, and then we examined, for example, a 265 gigabyte SSD, how many erase count did it consume? From our test, averagely only 150 erase count had been used. And based on today's MLC technology, it can perform about 3,000 erases. When we are designing a product, this product has to be validated so that we can give our customer a well-tested product. This kind of process is design, is validation. We tried to find ways to validate efficiently and offer the fastest service. For example, we used to have a firmware version that would cost 3 days to finish, and now with the help of Validation Lab, we can finish it in only 1 day. People today often talk about MIT, and our SSD are exactly made in Taiwan. We work at the same building as the R&D team, and we're both in Hsinchu, so when there is a problem in the manufacture pipeline, we as the PE team can perform a quick analysis on the problem and report it back to the R&D. And by working with the R&D, our problem can be solved very efficiently. In our manufacturing process, a full 100% test will include SPI, AOI, Agent, and FQC, and in each of the 4 processes, we will run a full 100% testing. I remember there was a time when I went to introduce our SSD to a client, and he asked me, "Hey, which module house does LITEON belong to?" People sometimes ask me, why did you make your SSD different from other companies in Taiwan? And I was stunned for a while when I heard this question. Then gradually, I realized that when we were designing our SSD, we actually inherited the same spirit that we used to design the ODD. Our customers are actually a little surprised to find that there is a company like this in Taiwan, because from their understanding, all companies in Taiwan are more like a module house or turnkey solution. And personally, I really feel that our approach in designing SSD was actually taken from our experience in making ODD, which is all about making things more useful. Inside the company, we try to let everyone in the company to communicate with each other and understand our project so that everyone will have a consistent goal. And outside the company, we tried to keep a good relationship with our customer and also pay attention to their feedback. I often encourage my colleagues to try to work hard and treat SSD as our second high-quality product so that LITEON can continue to offer better and better services to our customers.